Question 21. An angle with a measure of x degrees is increased by 45. What must be the original measure of x so that the resulting angle is equal to pi radians? Alright, so we have an angle with a measure of x degrees, and according to the problem, if we increase this by 45 degrees, it will be equal to pi radians. Okay? So to solve for x here, no, we have to convert pi radians into degrees so that everything is in degrees. No? And you can also tell that by looking at the choices. They're all in degrees. To solve this, we have x plus 45 is equal to pi in degrees. We know that for every pi radians, there are 180 degrees. And now we solve for x here by subtracting 45 on both sides. We have x is equal to 135 degrees. And that is the correct answer. And that is true. No? Again, if we increase 135 by 45 degrees, we'll get 180, which is equal to pi radians. Our answer is correct. 135. Next, question number 22. What is the reference angle for an angle in quadrant 2? Again, this is a recall question. Kindly remember that if an angle is in quadrant 1, okay, then the reference angle is itself, okay? Given that we're talking about the smallest coterminal angle. If it's in quadrant 2, okay, let me do it like this. So if it's in quadrant 1, the reference angle is theta. If it's in quadrant 2, it's 180 minus theta. If it's in quadrant 3, it's theta minus 180. And then if it's in quadrant 4, it's 360 minus theta. So the correct answer here is this, 180 minus theta. What is the smallest positive angle measure that is coterminal to 350? So we know that the SPAC, no, we simply have to either add or subtract multiples of 360 degrees. And for this case, since the angle is between 0 and 360, right? 315 is between 0 and 360. We just need to add 360. So 315 plus 360, we have 675 degrees. Number 24. A student finds that the reference angle for negative 210 degrees is 210 degrees. Is this correct? Why or why not? So first, if we actually tried finding the reference angle of 210 or negative 210, okay, we need to convert this first to its SPAC, the smallest positive coterminal angle. And since this is a negative measure, we need to add 360. So negative 210 plus 360, or that's the same as 360 minus 210, that is 150 degrees. And 150 degrees, no, is in quadrant 2. So its reference angle is 180 minus 150, which is 30 degrees. So the reference angle of negative 210 degrees is 30 degrees. So we already know that the answer is not correct. No? So no, because this. The reference angle should always be an acute angle. 210 degrees is not an acute angle. Okay? So what about this option? This option is incorrect because reference angles are measured from the x-axis, not from the y-axis. If we recall the definition of a reference angle, it's the angle formed by the terminal side of an angle with the x-axis. So say this one. No? This is the reference angle. So it's always formed by the terminal side and the x-axis. Number 25. In a right triangle, which of the following is the correct cosine ratio for a 30-degree angle? This one's very simple. Just type in cosine 30 in your calculators and that's it, no? If you want to use the unit circle, just imagine a 30-degree angle, okay? Since this is 30 degrees, the opposite side is shorter than this opposite side. Or sorry, the opposite side is shorter than the adjacent side. So we know that this must be 1 half and this must be square root of 3 over 2. And cosine is the x coordinate of this point on the unit circle. So this is x and this is y. So cosine of 30 is square root of 3 over 2. Okay? If you were asked sine of 30, that's the y coordinate of the point on the unit circle. So that's 1 half. Okay, but for this case, we're being asked the cosine. Again, you're allowed to use your calculator, so maximize it. Now type cosine 30 in your calculators. Next, a right triangle has one acute angle, 45 degrees. The hypotenuse of the triangle is 8 units. What is the value of sine theta? So actually, this is a bit of a trick question. This given right here is not necessary, no? Because we're being asked the sine of the angle 45. So regardless what the measures of the triangle are, no, the sine of 45 will always be the same. Okay, if you type in sine 45 on your calculators, that will always give you square root of 2 over 2. Okay, number 27. If r is equal to square root of x squared plus y squared, and that is the distance from the origin to the point P of xy, what is the value of sine theta? Now, this one is another recall question. Remember, if we have an angle wherein its terminal side passes through a point P with coordinates xy, we can form a triangle such that the side lengths of that triangle would be x here and then y here, and then this hypotenuse is just r, where r is represented by the distance between 0, 0 and this point xy, which is square root of x squared plus y squared. And we know that the sine of this angle formed is y over r, opposite over hypotenuse. So sine of theta is equal to y over r. Number 28. What is the value of secant of an angle in standard position formed by the point negative 6, 8? For this question, we need to use the right triangle approach. First, we must identify where negative 6 over 8 is. So that would be on the second quadrant. So 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So somewhere here. So the angle that we're talking about is this. Okay. And we can use the reference angle theta here, made with the x-axis, now, and create this right triangle, wherein the side length of this side is 6, or negative 6, sorry, and the side length of this one is 8. Now we need to know the secant of an angle. Now, if you recall our formulas, the secant of an angle is just a reciprocal of cosine. And cosine is x over r. So therefore, secant of theta is r over x. We already know the value of x, that is negative 6. But we do not know yet the value of r. Okay? We can solve for r using the formula r is equal to square root of x squared plus y squared. So r is equal to the square root of x squared, so that's negative 6 squared plus 8 squared. This is actually a Pythagorean triple. So if you already know this, then good for you. If not, then you can always use the formula. So r is equal to the square root of, so 36 plus 64. And 36 plus 64 is 100. Square root of 100 is 10. So the value of r, or this hypotenuse, is equal to 10. So therefore, the secant of theta is just equal to 10 over negative 6, or negative 10 over 6. Number 29. Is it possible for sine theta and cosecant theta to be positive in quadrant 3? So if we recall our algebraic signs, we use the mnemonic ASTC, meaning for quadrant 1, all trigonometric functions are positive. In quadrant 2, only sine and cosecant are positive. In quadrant 3, only tangent and cotangent are positive. And in quadrant 4, only cosine and secant are positive. So is it possible for sine and cosecant to be positive in quadrant 3? The answer is no, because only tangent and cotangent are positive in quadrant 3. So the correct answer is this. So no, because only tangent and cotangent are positive in quadrant 3. Last item for the multiple choice part. When theta is equal to negative 180 degrees, on which axis does the terminal side of the angle lie? Okay, so if we draw our Cartesian plane, so we have an angle in standard position, and since this angle is negative, we rotate clockwise. So this is 90 up until 180. So this is negative 180 degrees. So the terminal side of this angle lies on the negative x-axis.